Folks, welcome back. So I've really gotten interested in the literature on automatic patch generation recently, and today I want to look at some of the earlier work in this field. A few weeks ago we'd looked at a paper which generated patches based on a machine learning model, and today I want to look at some work which was a precursor to that, where the strategy was to generate patches based on patterns or templates that were extracted by looking at a large number of human-written patches. This work was done by researchers at the Hong Kong University of Science and Technology and published in the 2013 International Conference on Software Engineering. Just to step back and define the problem, the patch generation problem is not to write entirely new code from scratch, but to come up with patches to existing bugs. At a high level, their basic approach is to look at a large number of human-written patches and then try to extract the common patterns from them. Once you've identified those common patterns or templates, the algorithm here, which they call Pattern-Based Automatic Repair or PAR, uses those templates to generate a number of program patches. And finally, they test to see which of those patches are acceptable. We look at this paper in two parts. In the first part, we look at how they build their model or their list of templates, and in the second part, we look at how they then use those to actually create patches. For their raw data, they used about 62,000 patches from the Eclipse Java source code. Once they have this data set of patches, the next step is to try and extract some common patterns out of them. And the way they do that is to break the patches down to their graph-based model, and this lets them focus on the semantic content of the patch rather than its raw syntax. They then look at the difference before and after the patch. And from this analysis, they notice several common what they call fixed patterns, and they notice that the top 8 of these patterns cover about a third of all the patches that they looked at. And these will be pretty familiar if you've been fixing bugs in code for a while. These patterns are things like changing the parameters to a method, or adding a bounds check before accessing an array, or casting a variable to the right type before using it, adding a null check before accessing a value, and so on. The overall flow of their algorithm for generating patches is then, first of all, to localize where the fault is. Once they've done that, they then generate patches based on the templates that they've just found. And finally, they then evaluate these patches, and that is done by running the automated test suite for the program that they are trying to patch. For fault localization, the basic idea is pretty intuitive, and that is to run all the tests and then assume that the lines of code that are executed by the failing test case but not by the passing test cases are where the problem is likely to be. And then we go on to see which of our templates is applicable at that fault site. The way you do that is by doing a context check for the template. Each template has some kind of a context check which looks at whether you can apply that template in that context. For example, if you have a null pointer checker template, the context check will look to see if there are any object references at that point. And if there are, then we try to insert a conditional check to see if the object is null before accessing it. And once you've applied this patch candidate, you then run your test suite. And if all your tests pass with this patch applied, then the patch is deemed acceptable. So how does this strategy perform? In their tests, they tried to fix known bugs in a few very well-known open source projects, and these are their results. Overall, they tried to fix 119 bugs, and they were able to fix 27 of them. GenProg is a previous system that they compare themselves to, which uses more of a random mutation approach, and that was only able to fix 16 bugs. You can see here that for some cases it fixed slightly fewer bugs than GenProg, but in a few large cases it handily beats that system. It's interesting to compare this with the paper we looked at a few weeks ago that actually built machine learning models of patches based on their abstract syntax tree. I think the major drawback of this approach is that it relies on some sort of human input to form these patch templates. Whereas if you use a machine learning approach, you can build a model even for templates or patterns that a human may not be able to spot, and you'll get much greater coverage. So the template extraction or template discovery process is still human intensive and manual over here to some extent. Now that's only a one-time cost, and once you have a template, you can keep reusing it to generate patches. That's true. But with the machine learning approach we saw, you can automate even that, because that just becomes your model training phase. So as you can see, there's been a lot of active progress in the area, even in just the last few years. And this is a field I'm quite excited about, so I'll try to keep following it. I hope you enjoyed that, and I will see you next time. Thank you very much.